Hello, folks. Welcome to another episode of the Stupid CS Guy. Today, we have invited someone with around 3 years of experience for the mock interview. The problem is that he needs to build a web crawler that crawls the World Wide Web and indexes that in some format. As you already know, the videos are quite large, so I have bookmarked it to the exact point where I had feedbacks for the candidate. You can see those links in the description. Also, if you're interested in system design, want to learn more about it, join my system design group. The link below. That's a place where we have around 500 active folks talking about system design, talking about questions they were asked, and in general sharing articles. So let's jump into the interview.
Great. We have started recording. So the system that you need to build for today's interview is that we'll build a web crawler.
Okay.
So the system is going to start from few web pages and it is
Okay.
gonna crawl from starting from those web pages, to crawl the entire web.
Okay.
Now the system will expose an UI, a bare bones UI, where anybody
Mm-hmm.
can come and
Mm-hmm.
submit any URL.
Mm-hmm.
Okay.
Mm-hmm. Mm-hmm.
And those should be prioritized, those should have a higher priority.
Okay. Okay.
Okay.
Okay. Sure. So as I understand, the web crawler that we are going to design, it will be basically initially crawling in the few set of URLs, and there should be a mechanism that we can take input from the users, which URLs would need to be crawled on priority. This
Yeah.
is the initial requirements that we would need to cater to while we are
So
designing.
so the initial seed URLs can also come from the UI. So your system is all
Okay.
ready but it's not running. Somebody gives you
Okay.
an URL, so you start from that URL. Okay. So you
Okay.
start from that URL and then you start crawling. So you have to then go follow the links, get more. So
Mhm.
it could be like
Yeah.
you can say that the system admin gives a set of URLs into the system
Mhm.
using that
Okay.
UI,
Yeah.
and
Yeah.
then it opens up to the general public.
Sure. Okay. And the general public is not have the access to UI to submit the URLs, right?
They,
Is my
they'll have
understanding correct?
they will have access. Like for example, the
Uh,
reason they'll have access is, for example,
yeah.
you have a blog
Yeah.
and your web crawler is not crawling that. So you
Yeah.
come to the UI and submit your URL.
Okay. Okay. Got
Okay.
it.
So that
Got it.
the web crawler crawls your blog.
Sure. Uh, and the priority would be for the URLs that are given by the system admin. Than it
What
will be greater than the
whatever
general
comes
public.
from UI
Okay.
will have greater
Okay.
priority than whatever comes from, let's say, when you're crawling it, you get 10 outgoing links.
So in this problem, we are going to design a web crawler. You probably have heard of this problem a couple of times already. Now, I did a slight tweak to this. I said the web crawler needs to have an UI where webmasters can come and submit their URLs. The use case is, let's say you're building a new blog, you have a new website. You cannot wait for the search engine companies, let's say the Google web crawler, to come and crawl it. You need to tell Google that, hey, there's a new website. Can you prioritize this? And that's what the question is, that yes, you would have the web crawler pipeline. And I modified this a bit with saying that the user can come and request a new URL, and that URL needs to have higher priority. He's trying to get clarity on that part. He's asking a lot of questions, he's figuring things out, he's understanding what would be the seed URLs, what if a user does not submit any URLs. So all of those questions are for the requirement sections, and very rightly so, he's doing all that.
DB, uh, some kind of through some kind of, let's say, some batch update happened in the DB from the backend, so we can
Let's keep it
assume that.
simple. Let's just say there are only two ways it you can have. Either you have to give it
Okay.
through UI, or you'll
Okay.
just the system figures it out itself. So the admin doesn't do anything extra. The admin also uses the same thing as public users.
Oh, Okay, sure.
Okay.
So sure. And so these are the outgoing links that we have to crawl.
Yeah.
And now I think the functional aspect of the web crawler is to have some input, which is the URL links from the interface, and
Mhm.
we need to crawl them. And while crawling is being done, there might be some outgoing links that have to be crawled. Okay.
Yeah.
Now thinking about, yeah, now just thinking about the non-functional aspects, uh, I'll switch between the functional and non-functional intermittently to narrow them down, or maybe to resolve some ambiguities on the way. So thinking about the non-functional aspects, so non-functional I think would be one, maybe in the direction of the users who use that interface, and the number of users. And the second I think would be thing that we are actually doing is the crawling part, which happens on the URLs. So this I can say the I can label it as user URLs, or the number of pages that are being crawled, right?
Yeah.
So thinking about the user base, so I think there can be, let's say, uh, 10 million users initially that you are that are using the interface. What do you think? Is my assumption safe on the scale of users, or
Yeah. Let's assume that, um, people have submitted around 10 million links per month.
okay? So we are talking about 10 million pages or 10 million links per month. Okay, we are
That is
talking
what
about 10.
you're getting submitted. You might be crawling more
Yeah,
than that. You
yeah,
might be.
definitely.
Yeah.
Definitely,
Mm.
definitely. So this is the number of or the traffic that is coming through the UI,
Mm.
right?
Yeah.
Submitted through UI. Perfect. And definitely there can be outgoing links. So if I assume uh, some average number, the number of outgoing links that I get through per
Mm.
page, there could be some blogs where there is a less number of references, but there could be some research articles or some tech journals where there are, let's say, more than 10 references links per page. So
Mm.
if I assume an average of 5 links per page, uh, how would that look like?
Yeah. 5 links is makes sense.
Sure. So outgoing links, let's say 5 per URL. That is the average. And now, so what we have talked about until now is the number of users, which we are talking in the terms of number of traffic submitted per month in the links, and we have talked about outgoing links. And sure, so we are just talking about the web crawling part, or do you think that just taking the output of the crawling, I think the it would make sense if we have some kind of search functionality of the something that we have crawled. So do you think we should think about uh, search part of the crawled output in this scope,
No,
or
no, that is out of scope. So what you need to do is you need to
sure,
crawl and then you need to store. In a store, in a way, you can think of like, okay, I want to store in a way that something can be searched, but search is out of scope. But
search is out of scope?
just store. So you'll take the URL, get it, and then
Yeah.
you'll store it. Yeah.
Sure. So another functional aspect that I think is it would be the store or the persistence of the crawled output, and search is something we are assuming that it would be out of the scope, but it will definitely happen on the storage, on
Yeah.
the stored data. So our stored data, what I think is that stored data must be something like that. It must be searchable. So it must be in some format that supports good searching,
Yeah.
uh, easy on stored data. Okay, search
And
must be,
and another the most important part of the aspect of the system should
yeah,
be that your system should not crawl a web page like
yeah.
more than once.
It should not crawl it more than once. Sure.
Yeah, and
So
we'll keep it
that
simple. The web
yeah,
page could change, but we will keep it
yeah,
simple and
yeah.
we'll say it will not crawl more than once, even if it's 5 years.
Sure. So then what I can say here is that in the non-functional, it can help me reduce the number of crawlings that would go on, or I think I would not have to introduce some kind of a refresh mechanism then. So what we are saying is that, okay, so crawling once done is sufficient.
Is sufficient. You don't have to refresh, do nothing of that sort.
Sure.
But your system
So
should make sure that it is not crawling as much as possible, not crawling twice or more than
yes,
once.
Yes. So I think I can then label it as P0, something that I would need to think about
Yeah,
that. Okay, if the crawling is done once, it should not be done again.
yeah.
So I think
So in this part, he's writing the non-functional requirements. A better term would be constraints of the system. Kind of any problem that you design needs to be durable, available, low latency, and whatnot. So unless you have specific things to write, there's really no point wasting time writing, hey, it's to be durable and available. All of that in the non-functional requirements. I would rather want John to have a separate estimation sections. He tried doing some estimations, but it was not on point. Estimations should give you two values. It's super important that you come with two values, which is the amount of storage that is required and amount of bandwidth that you will consume. And those are the two values that is important. Any other calculations that you do, let's say somebody says design a email system and you come up with an estimation saying, oh, this system gets like 5,000 emails per day. Doesn't mean anything. It needs to have two things, storage and bandwidth. And that is what this section should have done.
think I missed the direction of that. Yes, coming back to the point that users are submitting the links. So
Yeah,
let's take this into account that system needs to be highly available as well.
yeah,
And in terms of performance, or in terms of, let's say, what should be the latency aspect once the link is submitted and the data is then crawled and then searchable. So I think I can split it into two phases. The crawling would happen. One phase would be the crawling that is happening on the link submitted, and the second phase would be the crawling of the outgoing links,
yeah.
right? So just trying to think in the direction of latency, right?
So
So
few
how
hours is fine.
few hours is fine. Few hours
Yeah.
is fine. Few hours to basically crawl the given link, and I am doing it in two phases. One being the link submitted, and other being the outgoing links. Right. Uh,
Yeah.
okay, so I think I have sufficient things to start with,
Mm.
and maybe if there is some ambiguity that comes up, I can try and revisit the requirements. So
Sure.
what do you think? Is it sufficient to head me into right direction, or am I missing on something?
No, this looks good. Yeah, let's start designing the system.
Sure. Just thinking from the first aspect that there is a client interface that is exposed, and
Mm.
the user are able to submit the links. So just one more question here. So should the user get some kind of notification that, okay, is your data already crawled, or if we just acknowledge that we have received the link and we will begin the crawling, which should be sufficient? I believe that
That's a good point. Yeah. So
yeah.
ideally, users will receive an email or something, but we can
Okay.
keep that out of scope.
Okay. So what we can acknowledge at the moment is, yes, we acknowledge that we have received your link,
That's
right?
it.
So
Yes.
so we can call it out. Then assumption is that at the time of submission, we just acknowledge of accepting the link to be crawled. But
Yeah.
in future, there might be some requirement where we would need to add a new feature to add email to the client or the user that your data is crawled and is available to be searched. Okay.
Yeah.
So yeah, so now as I was just talking about, there needs to be a client interface. So I think that there needs to be just talking about at a very bird eye view, how would the system at the high level look like? There would be definitely one client interface that is exposed to the client. or the users. And then after that has been submitted, I think there will be, let's say, a server, or we can call it as a processing layer. And the third, I think, would be the persistence or the data layer. So I think I can start with the system designing the system as a three-layered approach: the client, the processing layer, and the data storage layer.
Okay.
Yeah.
Let's not focus too much on the client.
Oh, okay, sure. So now, okay, so
Just let's limit
just
us ourselves to the backend.
sure, definitely. So just trying to understand in writing here, then maybe I can
Yeah.
just prior to shifting to the diagram part.
Mm.
So what I think is that there is some client layer which we do not want to focus in great detail. And here the main part is our server or the processing layer. And and the other is the important aspect of this would be the data persistence layer, right? So
Yeah.
this would, I think, it would look like. And so at the minimum, what I would do to begin with the client would be, okay, there is some front end application that is exposed, and with all sort of goodness of maybe load balancing, it can handle the different traffic and reroute to the corresponding servers. And then I think the important aspect of the server would come in, how I would be crawling it, ensuring that it does not crawl one page more than once, and it also adheres to the service to the number of links that have been submitted. Okay, so let's begin with that. What I think here is that definitely, since there is many number of users that are using the UI to submit their link, so definitely there would be that would not be able to happen without like using just one host or the one server. So there will be many some application servers that are running in, and I can safely say that they might be running through behind some load balancer. So let's see how it would look like. So let's say there are some users.
Mm.
I can just duplicate them to say that, okay, there are many users. Then what I think at initial levels is that there is some load balancer, uh, which is the public address of the API or the front end with which they are interacting. And I think I can safely assume it uses a round robin strategy, because the users round robin strategy of routing the request to different hosts.
Mm.
I'll just touch upon the point that why the round robin would uh, be safe here, and then I'll get started with the backend
Yeah.
part of it. So let's say these are different servers or the web hosts th- that are catering to the incoming traffic. Uh, so I put it here, and then I put it here, and I put it here. Yeah. So round robin strategy, why I thought would be good here, because the traffic would be non-uniform.
So you really do not need to talk about the load balancer internals here in this interview unless the interview specifically talks about load balancer. But then it's good to talk about some of these things. Tells the interviewer that you know what you are building. Just so you know, generally when you build large scale systems, you have several layers of load balancer. As in, you'll have one load balancer that's listening to the internet traffic. That is where the TLS termination or the SSL handshake happens, and that decides which geo to send it to. For example, you might have two data centers, one in US West, one in US East. The load balancer figures out for APIs, calls from this region, the US East is the one that replies, has a lower latency. So it sends to US East. Now, US East data center itself has 100 machines there. That is where you have another layer of load balancer, which does a round robin across these machines. So that's how generally the load balancer works. Not something that you should talk about, but mostly something that you should know.
My mind is, let's say I use some kind of some bucket that is holding on to which links that I have to crawl. if I think of bucket, so I am putting the links in that and I am taking it from one end. So I think it would boil down to maybe something using a queue. So
Yeah.
let's say I have some queue based structure over here, and what that queue based structure would look like is, let's say I have some message queue,
Yeah.
or it is holding on to the links submitted by the user, right?
Yeah.
And uh, right, and then there are other set of hosts that are running in the background and polling the messages from the queue.
Mm-hmm.
So they we can configure them at a frequency that they would poll the messages.
Okay.
And so at in this layer they would poll the messages.
When you have workers which get messages from the message queue, a more appropriate term is the workers listening to messages from the message queue. No, there are various ways to listen. You have a poll-based model, you have a push-based model. Um, that's the separate one. But you generally should say that workers are listening to messages. That's what a more appropriate term is. The way it works is, let's say you have a lot of stream of messages, and you have workers. When you configure your workers, you tell your workers saying that, hey, you can consume 10 messages parallelly from the queue. So once you get 10 messages, the worker starts executing. The moment one of the slots open up, the worker goes back to the queue. Either it could be asks the queue, or the queue sends a shoulder tap, something like that, and gets the new message. So it's not like it's always polling. So the term that I would like to use is the workers listening for those messages.
Of these set of hosts would look like that. They would like load the link. They would like load the link, right? And uh, the content, there will be the text content. So since I'm the searching from the users would happen on the text, so I'll restrict it to the text part. And they will also keep track of the outgoing links that are available in the contents of this page, right? So
Yeah.
now there is the two part. Once the processing of the text that has come in, and the outgoing links that have surfaced in the uh, content of the URL, right? So what I can do is that if I have some outgoing links, I think I can safely say that, okay, since the links are the part of the queue, so I'll add it to the queue again, right? If there are some
Yeah.
outgoing links, uh, the, these hosts, they will submit it back to the queue, so that
Yeah.
those links could be polled and at a or to be crawled at a later time.
Okay.
So so just a feedback loop here. uh, yeah, this kind of feedback loop for outgoing links.
Okay.
Yeah. And then I think the aspect that we have to take care is the text part, how
Hmm.
the text processing would look like.
Hmm.
So, and I think there is one more open request that I'll visit in some time. Is it was the that it should happen only once, right?
Yeah.
We listed it somewhere. Okay, it was something here. Yeah. So it should happen only once.
Hmm.
So how it would look like is that so there must be some uniqueness that must be ensured, because
Yeah.
multiple users can submit the same link, and I
Mm-hmm.
should not crawl that again. So
Correct.
I think there is some kind of interaction that must be there, or there must be some kind of uh, uniqueness to introduce. So I think with uniqueness, something that strikes my mind is some kind of unique reference ID.
Hmm.
And that unique reference ID, it could be, let's say, key generated based on the URL text, or the
Hmm.
URL values, something like
Hmm. Hmm.
www.xyz.abc.
Hmm.
So slash something. So to generate that, it could be output of a hashing algorithm. Let's
Hmm.
say it industry wide, that would scale, I think, to ensure uniqueness would be, let's say we can use MD5 algorithm here.
Hmm.
So then one thing I would introduce here is some kind of data store.
Mm.
And let's say it is a key value data store, right?
Mm.
And when the these servers will poll the messages from here, they will generate the hash.
Now, this is an important concept to have. An MD5 checksum is a 32-bit integer value that is generated on the contents of the file. If two files have the same MD5 checksum value, those two files are same, and it is used in a multiple system design interview problems. Like he's using the way to figure out if the URLs are same. It could also be used to get the actual value of the URL, as in the HTML page, and check if that has already been replicated. It can also be used for designing systems. Let's say something like a file syncing server, Dropbox, where you check if the file has already been uploaded, the chunk is already been uploaded somewhere. So you do an MD5 checksum and check. So there are multiple places that this MD5 checksum is used. So make sure you have that concept in your bag.
Behind
So,
using an interface.
okay, when you're
Yeah,
crawling, you also need to store the crawl data, right? How are you storing the?
definitely.
Yeah,
Definitely. I'm coming to the text processing part. Just
I see.
I'm touching upon that part.
I see. I see.
Sure. So now I think it is the canvas is a bit crowded over here. So I'll just so these are the two layers that we talked
Yeah.
about. Now
Mm.
I think would come to the part of the data storage, right?
Yeah.
And the text processing part where we need to store that data.
Yeah.
So so this is some kind of text data, right? So there could be multiple approaches, but as we talked that our data needs to be searchable as well. So it should be on some kind of uh, storage that okay, it would look like that if I have some word, let's say a book, maybe one thing that comes to my mind is, let's say, alchemist. If the
Mm.
user would type so just taking a one step back to think around what the data storage would look like. So as we talked about, it needs to be searchable and it
Yeah.
needs to be persistible. So I think if the crawling has been done and these are text, mostly words, so this could be this needs to be queryable faster.
Mm-hmm.
If I think about queryable faster, something hits my mind is indexing.
Mm-hmm.
And what another aspect is to be taken care of is that there could be multiple links. Let's say link 1 which contains the word alchemist, right? Link 2 which contains the
Now, the best way to talk about this is just to simply say that we will have a worker listening to the queue, which will analyze these HTML pages and put them in Elasticsearch. And read a bit about Elasticsearch. I don't think any interviewer would expect you to go into the details of how Elasticsearch work. But good to know a few basic points of how it indexes and how it works. And yeah, that's about it. You don't really need to go into the nitty gritties of it.
let's assume we are having 1,000 words per page,
Yeah.
right?
Yeah.
And 1,000 words per page, and for 1,000 write we would need to do in our DB for one that for this word, this is the link they are coming out of,
Yeah.
right? So
Yeah.
so our data storage needs to be so there will be a write intensive traffic first of all, that when we are
Yeah.
querying. And for this write intensive traffic, I think the data storage that we use must support that. And
Yeah. Let's just assume that you are using some storage which can do all of that. Okay.
yeah,
So you have a system which can index.
yeah, yeah,
Just let's just assume that. Then think about that. You spoke about this system which listens to the queue, and then it
yeah,
just puts into the outgoing links. And so you can have a system which talks to that system, and that system can work on indexing all of that. So you don't have to worry about
Mhm.
it. So just
Sure.
use that as a black box.
Sure. So, so initially, then what comes to my mind is that after uh, this servers, they do the processing for these texts, so they would interact with some layer that okay, for this key this is the link, for this key this is the link. And I think the data storage which would fit here. So just to avoid some confusion over here, so this was for uh, just updating the text value here. uh, this was for unique reference of the link, and we have some data layer here. Now it is the key value storage,
Hmm.
where the key is the word
Hmm.
and value would look like the link from which it came out of.
Yeah.
And there is some kind of mechanism here, right? I think we can unfold it. So
Yeah.
where these servers are interacting with this piece, and they are submitting it as input, let's say a word and a value,
Hmm.
and this is, let's say, a proxy, and
Hmm.
this would then update the this data store over here.
Yeah.
Okay, because it would be a good practice to expose this data store directly, so
Hmm.
I'm assuming that it is running behind some proxy,
Yeah.
right?
Okay. Yeah.
So okay, so just I'll go through the design once again of the system that is in the current shape, to see if I have not missed anything.
Yeah, let's take
And
one flow. Let's take one flow. If a user submits the request, what all happens? Let's just go through that.
sure. So this is the user.
Hmm.
He accesses the interface from this public IP
Hmm.
on which the application is running. So he submits the link, right?
Yeah.
And what will actually then happen is that the traffic would come based on the round robin strategy to any of
Yeah.
these particular servers.
Yeah.
So these servers will basically invoke some cloud queuing SDK,
Yeah.
or the message queue SDK,
Yeah.
and they would submit they would submit the message, or push the message to this queue,
Okay.
right? And then they will get an acknowledgement if the message was successfully submitted.
Yeah.
And let's say so each message will have a unique ID, and
Yeah.
the client initially gets that unique ID in response. Okay.
Okay.
uh,
Sure.
so this is what has happened in the synchronous
So,
aspect here.
okay. You spoke about unique ID. So, where does the unique
Yeah.
ID get stored?
So let's okay, so I think we can visit that part later if we want
Okay.
the unique ID at a later stage. But if we want that unique ID, so let's say that
Let's say we don't no need unique ID because they don't need to refer it. Let's just for a moment just make it more simple. Okay. So it goes into
sure.
message queue, and
Yeah,
then from then what?
yeah, it goes into the message queue, and as we talked initially, that these are the API, or these are the servers that are polling the messages from the queue.
Yeah. Yeah.
So these will poll the messages at some given frequency,
Yeah.
and which is configured. So based on that, they will load the link,
Yeah.
they will do the text processing, and for
Okay.
the text processing, as we talked, that they will submit the word and the link uh, to this proxy, for the word which came out of this link, right?
Yeah.
And there will be some outgoing links as well. In this feedback loop, these servers will again push those links to this particular queue.
Okay.
And
Okay.
just taking a step back, I think I missed that step to explain. So these servers will also hit this, will compute the URL hash key, and they will interact with this key value store to see that if this link was processed in the past or not. If it was, then they can drop that message.
I see. I see. Uh, what happens if, let's say, you have the same web page being hosted in different domains? That normally it's quite common.
Yes.
There's mostly like two constraints of the system that you have to think while designing. One is that we do not want to crawl web pages twice, even if they're in the same frame or different URLs. And the second, you have to prioritize the user's request. And remember last time I talked about how important is MD5 and Checksum. See, it's again applied here.
Okay, so we need to ensure some uniqueness over there. So let's say if there are 1,000 words per page, right? And if we compute the unique, so we would need to introduce some kind of unique mechanism for the
Mm-hmm.
content as well, right?
Mm-hmm.
So to do that, let's see what we can do. uh, Again, something that comes on top of my mind is computing the hash of the entire content of entire the text of the page, but I'm not sure if it would scale.
Mm-hmm.
Or what else we can do is that if we split the pages, if we split the content of the page in some batches, right, and
Mm-hmm.
then compute the hash, so it can be computationally uh, less cheaper, in the sense that, okay, so that strategy would look like is that I'm not like sure, but I'm trying to evolve it. So it would look like 500 words, since we have assumed 1,000 words per page, right? So we can.
So what John is trying to do here is he wants to save on compute by not doing an MD5 checksum of the whole document. It's good that he's thinking about optimizations, but I would suggest in a system design interview, come to the optimizations at the end. And there are various types of optimizations you can do. You could say that, hey, I am denormalizing the data, so there's a lot of storage, so I might want to optimize that, which should be the lowest priority because storage is cheap. Something that is taking a lot of compute, maybe like this one, you can come and optimize that part. And but in this case, I don't really think we should spend a lot of time on the optimization side, especially because your latency is high because of the network round trip, and the MD5 checksum calculation would be a small part of it. And by the way, the MD5 checksum is something that happens in Git in multiple other systems, so it's not really as costly as you think it is.
That would look like I'll store this hash of at the content level. So I'm storing the hash of, let's say, a one batch of content, right?
Yeah.
And this can happen maybe in another table in this key value store itself.
Okay.
And
Okay.
as we are interacting with this in the with the hash of the URL, maybe we can also interact with this key value
Sure.
store uh, uh, at the second step also, after
Sure.
computing text and prior to submitting it to the key value store
Okay. Okay.
for the
Okay.
links, which stores the
Okay.
links.
So let's go to the next question, which is how do you ensure that you have the priority for the user submitted URLs are more
Mm-hmm.
than the
Mm-hmm.
priority of your outgoing links? Currently, there's no way to ensure that, right?
So one way, okay. So I think the one way to ensure that is that in the message queue that we have used here is, right. So we are polling in. We are take first of all we are crawling the links that are the part of or submitted by users. But yeah, I agree with you. Currently, there is no actively distinction between the outgoing links and the user links. So I think that could also be handled better. In one different way that comes to my mind is, let's say, I have kept some kind of queuing mechanism that
Mm,
is accepting the links from the user. So this feedback loop here, right? Uh,
mm,
I I I can route it to another queue,
mm.
and so these so it would look like, I'll just remove this arrow and I'll bring in another queue here, right? So let's say this is the queue that is storing the outgoing links.
Okay, got it, got it. Yeah, this looks good. So,
Yeah.
what do you think?
Like I said, one of the constraints of the system was making sure the user submitted URLs have a higher priority. And he is using two queues to achieve that. One that distinguishes between if it's a URL that was submitted by the system, and another which is just for URL submitted by the user. This also makes sense because then you can scale independently. You can have like 2 workers listening to the one that is submitted by the system, and you have 4 workers which is listening to the one submitted by the users. So that makes a lot of sense there.
Some kind of mechanism over here that
Mm.
the data is sufficiently replicated,
Mm.
so that can be used at later point of stage for by the indexing service that was available as a black box to us.
Yeah.
And that I think this can also be done in various approaches, right? So one way of so this is the caching part. So what we can do is that we can first of all avoid that all the links, all the hashes are stored in this one particular replica, and or sorry, one particular key value store. So let's say there is some read replica of this,
Mm.
right? And if this and this is the master instance.
Mm.
So if this goes down, but
Mm.
we are using this key value store here to check if the URL or the link was already polled or not. So initially, let's say that these all servers are interacting with this highly available key value store. But if it goes down, so but after we are computing the hash, right? This is asynchronously replicating this slave over here.
Yeah.
Okay. So
Yeah.
this is a slave of this, and it is asynchronously replicated. So we can be sure of that at least our previously computed hash
Got
are
it. Got it. So
like
let's look at what if one of these message subscribers, right? Message queue. If one
yeah.
of them goes down, what's the impact to the
Mhm.
system?
Yeah, so here the impact is here the impact would be critical. That if currently we have assumed it to be a one message queue where all the links are submitted, right? So here all the crawling aspect of our system will go down.
Mm.
I think we can split it since we have the leeway of it to be done in few hours, right?
Mm.
And how I think this can be done here is that, so let's say we have this message queue over here, and what then would be done is we can split it into two components, right? And
Yeah.
that component would look something like this. I'm just since there is less space, I'm shifting it a bit down, right?
Mm.
So this message queue over here, okay, this is just a text part. Okay, I'll just copy this. So yeah, so this message queue, if we duplicate it, right? So uh, like these servers are interacting with different set of queues,
Mm.
but that would mitigate it to like some extent, that okay, all our messages are not being not being serviced, but there will be some messages that would be lost. But we definitely want that we should since we have given the acknowledgement to the user that we will for sure process your link, right?
Yeah.
So what another thing comes to my mind is that apart from the separation of this queue, right? So
Mm.
let's say this we have a message accepting service, and then there is a message dispatching service, right?
Mm.
or or what I can say here is that, so it would look something like this. uh, let's say we have this message dispatch, a message accepting service. uh, if message accepting service, and if we and then we have some kind of data persistence over here,
Mm.
and then we have a message.
Now, this is a slightly tricky question as to what happens when the main message queue goes down. Now, the first thing to understand is when a disaster strikes, you would lose some data. Now, how much is the part that you can control. For, let's say, with the message queue, you would have several options. One is called an active-active model. Active-active model is where you take the same message and you put it in two queues. And at some point in time, you deduplicate. So if you put in one message in Q1 and the same message goes to Q2, and then Q1 goes for a task, you still have Q2, and when the worker listening to Q2 message tries to deduplicate, it says that, oh, this is the first time I'm receiving the message. So it processes it. Can you lose messages here? Yes, you can lose messages here also. For example, while you are making dual writes from your UI layer from into queue, so you are putting one message in Q2 and one message in Q1, and maybe the Q2, you put the message in Q2 and your system goes for a toss. And system goes for a toss and disaster strikes in that data center. So message did not get put into Q1. So you still have some data that you might lose. Now, there's another option is the active passive model where you have one queue which is active and the second queue which is in a separate data center which is not active. And if the Q1 goes down, the machines start sending to Q2. This is called the active passive model. So the idea is you lose some amount of data. For the second case, the active passive model, you lose the data which is in the queue, which will probably be few seconds. So it depends. Again, it's a trade-off problem on how much data loss is your system resilient to, and that's how you design. Generally, in the interview, I would go for an active passive model just for the simplicity. There might be specific design questions, mostly for senior engineers, but the only topic is disaster recovery. That is when you should explore options like heartbeat, how to know that there is a disaster, how do you have a somebody to check whether there's a duplicate message or not, and all of that. Mostly for most of the interviews, you can just go for an active passive model, and that should work.
I got it. We are out of time, so we'll end the interview here. Okay.
Okay.
Yeah.
Sure.
Thank you. Once.
Overall, I think the interview went pretty well for someone with 3 years of experience. He knew a lot of stuff, went pretty deep into some of the areas. Some of the areas of improvement is probably the structure, mostly around estimations and non-functional requirements. Those could have improved a bit, but overall, I'm pretty happy with it. Let me know what you think, and if you want to reach out to me, you have the links below in the description. I am active in my Telegram group, on LinkedIn, or just comment in this video. Make sure to like, share, and subscribe, and let me know what you want me to see doing next.